Okay, I think we can begin. Welcome everyone for joining today's talk. It's great to see so many of you here. There's already 60 participants, and so it's great to see such a great crowd today. Thanks for making time during your lunch hour to join for this event. Before we begin, I just want to introduce myself and Bay Nature. My name is Leah Keener, and I'm Bay Nature's events coordinator. Our event program is all based around our magazine content, which many of you are probably more familiar with. We're a quarterly print publication based in Berkeley, and we're a nature nonprofit organization that focuses on conservation and nature topics, all local to the 9 counties of the Bay Area. But in addition, we're also working on building up our events program with virtual events like this one, as well as in-person outings and bio blitzes and special events that are going to happen in the next few months as well. So thank you so much for joining to support Bay Nature and to support our events program. It's really great to see you all. And biggest thank you of all goes to Pete for joining us today, sharing his time and sharing his expertise all about birds. So without further ado, I'd like to introduce Pete as our speaker. Pete Warzybok is a principal scientist and Farallon program leader with Point Blue Conservation Science. Point Blue is a research-based conservation science nonprofit whose mission is to advance the conservation of birds, other wildlife, and ecosystems through science, partnerships, and outreach. Pete's work focuses on the ecology and conservation of marine ecosystems, overseeing research activities at Point Blue's long-term research station on the southeast Farallon Island, and maintaining our long-term monitoring data on the populations, breeding success, phenology, and diet of marine birds and mammals. Thank you so much for joining us, Pete. So we'll transition to the talk part soon, and I just want to ask everyone who's here to please turn your cameras on if you're able. It would be great to see your faces for the duration of this talk. Would love to see you. And if you have any questions, please drop them into the chat. And we will get to as many as possible after the event. And how that will work is I will read your questions out loud and we'll get through as many as possible. But with that, I would like to turn it over to Pete. Thank you so much, everyone, for joining us.
Great. Thank you very much. I believe, have you released screen sharing?
Yes, I have.
Okay, here we go. And do you see my title slide now?
Yes, looks great.
All right, perfect. All right, well, thank you very much, Leah, for that nice introduction. And it's my great pleasure to join you all today to talk about one of my favorite places in the world, the Farallon Islands. Today's talk is a follow-up to a great article by Jesse Greenspan that ran, I believe, in the October issue of Bay Nature, titled A Trip to the Farallones to See Birds on the Edge. And in that, or to prep for that, Jesse was lucky enough to actually get on a media trip out to the Farallones. He actually got on the island, got to speak with some of our biologists there, and then I spoke with him as well. And he got to learn a little bit about the wildlife and the work we're doing out there and put that in his piece. And so I'm using that as the inspiration for the talk today. And you'll see kind of a recurring theme here about things on the edge. First, let me just start with a little bit of background. As Leah mentioned, I work for the conservation nonprofit Point Blue Conservation Science. I have been working on the Farallones for 25 years now, literally half my life. And I've spent more nights living and working out there than any other human ever has. So it's really a special place for me. It's a second home, and it's a place I care deeply about. So it's great to get to come here and speak with you about it today. A little bit about Point Blue. As I said, we're a nonprofit. We were founded in 1965 as the Point Reyes Bird Observatory. Back then, there were only a handful of people, I think 6 folks, who started a little bird observation station on the headlands off of Point Reyes here near Bolinas. But we've grown extensively over the last 60 years. In fact, we're celebrating our 60th anniversary coming up in a couple of months. Now we have over 200 seasonal and full-time staff doing conservation work all the way up and down the coast, from Alaska all the way down to Antarctica, and from the ocean inland to the Central Valley, up into the mountains, and even to the Great Basin. I believe Leah already read what our mission is: to advance conservation of birds, other wildlife, and ecosystems through innovative and rigorous science. powerful partnerships with other conservation nonprofits, with universities, with management agencies and others, and through outreach like we're doing today. And the overall goal of our work is to reduce the impacts of environmental change and to promote nature-based solutions for both wildlife and people so that everyone can benefit from nature. Of course, we're here to talk about the Farallon Islands, and the Farallon Islands are a national wildlife refuge. They're originally established in 1909 by Teddy Roosevelt as a preserve for breeding birds. So even way back in the early 1900s, people recognized how important the Farallons are as a breeding site for marine birds. When it was established, though, the refuge only included the North Islands and the Middle Islands. It did not include the South Farallon Islands. Those were instead managed as a lighthouse station and later as a military base and a Coast Guard station. Biologists from Point Reyes Bird Observatory, now Point Blue, first went out there actually in 1967 and established a permanent field station there on April 3rd of 1968. And we've had people on the island every single day since then, without fail. About a year after we got there, the refuge expanded to include the South Farallon Islands as the Coast Guard was turning over the station to the U.S. Fish and Wildlife Service. And that way the main islands were included in the refuge. And ever since that time, I guess about the early 70s, we've been working in very close partnership with the U.S. Fish and Wildlife Service through what's called a cooperative agreement to provide the science, the research, the monitoring to U.S. Fish and Wildlife Service so that they can effectively manage the wildlife resources and the habitat on the islands. And we also provide stewardship for the wildlife resources through just the fact that we're always there watching for things. One other thing to note, the Farallon Islands National Wildlife Refuge is closed to the public. It's a very sensitive area. The wrong people at the wrong time could cause a lot of disturbance. So we try to keep the human presence to a minimum and only people who are there doing mission critical work. So where are the Farallon Islands? Well, if most of you are in the Bay Area, you probably have seen us. We're fairly close ashore, about 30 miles south-southwest of the Golden Gate Bridge, a small group of islands consisting of 3 island groups: the North Farallon Islands, the Middle Farallon Island, which is just one that barely comes above the surface, and the South Farallons, which are the main islands where we have our research station and where the only human presence is. All told, there's about 8 main islands and several smaller islets and offshore rocks, totaling just over 200 acres of actual land. So to put that in perspective, that's about 1/3 of Golden Gate Park. You could fit the entire Farallon Islands into 1/3 of Golden Gate Park. So it's physically a very small area. And so what you're seeing here is the map showing our location, a little zoomed in map to show the different island groups. And then the picture there is our main island where we live and work, and you can see our houses in the foreground. And then just one other little fun fact, we are actually within the city of San Francisco. We're part of the city limits. So with almost 60 years of habitation on the Farallon Islands and the diversity of wildlife that we have, there's so much more going on out there than it's possible for me to talk to you about during our short time today. But here's a kind of a brief summary overview of some of the wildlife that we find on the refuge. Of course, the Farallons are the largest seabird breeding colony in the continuous United States, so that's the U.S. outside of Alaska, with over 500,000 breeding birds during the summer. That includes the world's largest colonies of ashy storm petrels, Brandt's cormorants, and western gulls. And for ashy storm petrels, or for a small threatened seabird, we actually host about half of the world's population on the Farallon Islands. The islands are also critical breeding and haul-out habitat for pinnipeds. So those are your seals and sea lions, including California sea lions, Steller sea lions, northern elephant seals, fur seals, and harbor seals. We have an assortment of unique native species, including an endemic salamander, an endemic cricket, and other native plants and invertebrates that are found only on the Farallons. For a long, long time, the Farallons have been known as a migrant hotspot. It's a really great place to study migrant birds and vagrant birds, ones that are lost and find their way out here. The refuge has the largest bird list of any national wildlife refuge in the entire system. And we have the highest eBird hotspot in all of North America, with more than 440 species having been observed. The waters surrounding the island, of course, are also really important for whales, white sharks, and lots of different types of fish. There are also countless invertebrates, fish, plants, and other unique biological resources in and around the island. So it's really a diverse and wild place with lots and lots of wildlife. Now, one thing you might think about this really small group of islands close to a major metropolitan area, you might be thinking, well, why are the Farallones such an amazing hotspot for biodiversity? And the key really is location. So the Farallon Islands physically are on the edge of the continental shelf. So in that figure, you can see on the right is a map showing the bathymetry and where the Farallones are. That red line is what's called the shelf break. And that's where the water depth goes from only a few hundred feet around the Farallones. It suddenly drops off to over 2,000 feet. And being close to the continental shelf break is actually really important and one of the major drivers for why the Farallones are a productive place. We have a phenomenon known as upwelling that occurs along the coast. And this is where the winds blowing along the shore push that surface water out away from the coast. And then that's replaced with water from down deep off of the continental shelf break. So that real deep 2,000-foot water is brought up to fill in that gap. And with it, it brings lots of nutrients up to the surface and makes it available to wildlife. Things like phytoplankton, zooplankton, fish, marine birds, marine mammals, and so on. So that really high productivity driven by upwelling and our location right at the edge of the shelf break is what supports all of this abundant wildlife at the Farallones. So for the rest of my talk, I will focus primarily on seabirds. In my heart, I am a seabird biologist. I started working with seabirds 27, 28 years ago as an unpaid tech on a small island in Alaska. And I instantly fell in love with seabirds, and I've worked with them ever since. Besides being really cool, seabirds are great indicators of the health of the marine environment. They're like, the proverbial canary in a coal mine. Changes in the marine environment, perturbations, changes in prey base, warming conditions, introduction of pollutants, anything like that is felt by seabirds, and we're able to measure that by following their productivity, diet, population, and so on. These are the 13 species of seabirds that we find on the Farallon Islands. There are 5 species of alcids, so those are diving seabirds that use their wings to propel themselves underwater in search of prey. And that includes the common murre, Cassin's auklet, rhinoceros auklet, tufted puffin, and the pigeon guillemot. We also have 3 species of cormorants, the double-crested, pelagic, and Brandt's cormorants, western and California gulls, and 2 species of storm petrels, the ashy storm petrels, which I already mentioned, about half the world's population on the Farallones, and then also a small population of Leach's storm petrels that breed. And finally, black oyster catchers. Even though they're a shorebird, we count them among the seabirds and we study them as well. So the question is, what are we doing with all of these seabirds? And the real thing that we're trying to do is this long-term monitoring. Long-term monitoring is the key to Point Blue's mission and to our success. It is our superpower. Long-term monitoring, having this incredibly long time series of data on the Farallones that goes all the way back to the late 60s. This allows us to detect change and then to put that change into perspective and context of the long term. So if we have a poor year where birds aren't breeding well, or we see a population decline, we're able to look at this and determine, well, is this just a blip? Is it a one-time poor year? Or is this part of a larger trend that we need to start thinking about? Long-term monitoring data also contributes to our understanding of ecological mechanisms. What is happening in the environment? How does that impact different species and different parts of the ecosystem? What are the functional relationships between them? And it also allows us to assess threats, such as warming oceans, overfishing, entanglement, etc. And then to document recovery. It's just as important to be able to document recovery from disturbance as it is to identify threats to the seabirds as well. So this long-term data we refer to as the keystone to our work. I'll go through and explain a few of the long-term data sets that Leah mentioned in the intro that we're collecting. So the first one is breeding success or reproductive success. Seabird and pinniped reproductive success is a very good indicator of overall ecosystem health and productivity. Poor breeding success might signify changes in prey availability or poor environmental conditions. The presence of contaminants like DDT or disturbance to the colony. And the way we study the breeding success is by following these birds throughout the season. So we get there early on, we look to see which birds are returning, and we follow them from egg laying until the chicks fledge. And we keep track of how many birds breed, how many lay eggs, how many of those eggs hatch, and how many ultimately fledge. And so what I'm showing here is kind of the breeding season chronology for the common murre, starting with laying eggs and then hatching a small chick. Then we have an older chick that's probably about 18 or 20 days old. And then finally that chick taking off and going to sea for the first time. We also study population size. Very simply, how many are there? And also, how does that change over time and what's driving that change? Keeping track of populations is extremely important in detecting changes in the environment because the seabirds are very sensitive to those changes. So here I'm providing an example from Brandt's cormorants, one of the species that I pointed out before. And you can see between the 2007 photo and the 2008 photo, we actually had a large population crash. It went from about 22,000 birds down to only 6,000 or 7,000 birds in 2008. And after studying this for a few years and looking through the data, we determined that this was due to warmer than average water temperatures and a decline in one of their most important prey, the northern anchovy. So there wasn't enough food for them during the winter of 2007 into 2008 and during the 2008 breeding season. They didn't have enough food to make a breeding attempt and to raise chicks. And consequently, also not enough food to maintain themselves. So we saw a large die-off. And this had a long-lasting impact. The population didn't actually recover to 2007 levels until about 2023. And then during this past winter, from 23 to 24, we saw another population decline. And again, it seems to be related to warmer water as we had an El Nino and a decline in their preferred prey. But it's too early to know if this is a long-term decline like we saw in 2007, or if this is just a blip driven by poor conditions and those birds have survived to come back and breed next year. So we'll keep monitoring to find that out. We also study the diet and foraging ecology of seabirds. Diet helps us really to understand changes in the ocean and how that affects forage fish and crow. Seabirds are extremely skilled predators. They're very good at going out and obtaining food in this vast, seemingly uniform environment of the ocean. And this makes them excellent samplers. They go out and they collect the data for us and bring it back. And we're asking questions like what prey resources are important to these birds? How far or how hard are the animals having to work to go find food? In some years, fish are concentrated right around the islands and it's very easy and they're very abundant. Other years, they're less abundant and they're more scattered and the birds have to work harder to go find it. We also learn a lot about the prey populations themselves and where those are concentrated and how their populations are changing. And then we can look at, well, what can we do to protect those prey populations to make sure that they're available for seabirds? So this collection of photos is basically just showing a few different ways that we go out and we collect this diet information. In some cases, literally the birds just bring it back to us. We sit in the blind and watch a murre bring a fish in to feed its chick, like in that left-hand picture. Sometimes it's picking up fish that birds have dropped as they're coming back to feed their chicks. Or in some cases, like the kind of central left photo on the bottom, birds will regurgitate a little pellet, much like an owl does, that has indigestible parts, and we can identify what the prey was from that. And we can also use devices to look at their diving behavior. So this Cassin's auklet has a little device that tracks how deep it dives and how long it dives. And we can get a lot of information from that. And finally, we look at dispersal and movement. So where are these birds going when they're not at the Farallones? Helps us identify what are important foraging locations for them. It also helps us identify potential impacts away from the colony. There's a relatively small portion of most seabirds' lifespan is spent on the breeding colony. Most of it is at sea. And so getting information about where they're going and what's happening when they're away from the colony is extremely important. So this example is a study we did a few years back where we looked at the movement of pigeon guillemots during the winter. Prior to this study, we actually had no idea where they went. They would disappear from the island in late August, early September, and then not be seen again until the following April. But we were able to put these small little devices on them that keep track of daylight and help us to determine their positions. And we learned that they're actually making a long reverse migration up north to British Columbia and Alaska and spending the winter there. So that's really important information. If we were to see some kind of decline or population impact, we would not only look at what's happening locally at the Farallones, but we also might want to look at what's happening up in their wintering grounds. So these are all the different types of information that we're collecting, some of the types of information we're collecting. So earlier, I spoke about Farallon seabirds physically being on the edge of the continental shelves, but seabirds are also on the edge from a figurative standpoint. Globally, seabird populations are in steep decline. More than 70% global seabird population decline since about the 1950s. Seabirds, as I said, they're great indicators because they are sensitive to changes in ocean conditions, but that also makes them vulnerable when we see large-scale changes. And it's a very delicate ecological balance between when conditions are good and when conditions are bad. And if there are poor conditions or there's repeated disturbance or there's introduced predators, that can push seabirds over the edge to the point where their populations are declining. And these are a few of the risk factors that are fairly common for seabirds. Of course, climate change, things like ocean warming, severe storms, frequent and intense anomalies like El Niños. This is an overarching thing that affects all marine wildlife and pretty much everything in the world, but is something we study with seabirds. Another risk factor is habitat disturbance, things like physical changes like sea level rise or the introduction of predators or changes in habitat. Pollution, microplastics, oil spills, things like that. Food depletion, if there's reduced productivity, there's fewer fish out there, or if there's competition with other sources. So if birds and other marine life are competing with human fisheries for limited resources. And sometimes you get dead zones during poor years where there's oxygen limited and there's no productivity. So these are a few of the identified threats for seabirds. Today, obviously, I'm not going to go through all of these things, but I'll focus a little bit on ocean warming and climate change. This was a topic that I spoke with Jesse about when he was writing that article, so I thought it would be appropriate to revisit it here. And so ocean, I think most people know that not only is air temperature increasing, but the oceans are getting warmer every year. So this figure shows global average ocean temperatures and how they've been rising over the last 100 years plus. And you can see that we're in that red zone and it just keeps going up and up. So we're well above the long-term average. And in fact, 2024 was the warmest year on record for the planet. And this resulted also in ocean temperature reaching a record high. The oceans are very good at absorbing heat and holding that heat for a long time. So as air temperature rises and the planet rises, or planet warms as a whole, ocean temperature is rising and holding on to that heat. And another indicator is that sea ice extent was about the lowest on record in 2024. Again, a factor of warm air and warm water temperatures. So this has a lot of different impacts on marine wildlife. It can cause lower primary productivity, so less phytoplankton being produced. That can reduce prey resources. So there's no zooplankton and no fish because there's no food for them. Warming oceans can cause changes in species distribution. Species that are more adapted to warm water are moving into areas, and species that are more adapted to cold waters are declining. You can see changes in water chemistry, so increased acidification, lower oxygen levels, things like that as the oceans warm. Of course, the physical factors that I mentioned, sea level rise, increased storm intensity, and then an increased frequency of large mortality events, like the one that affected the Brandt's cormorants in 2007, where seabirds just don't have enough food to survive through the winter, and we end up with these large mortality events. In addition to general constant warming of the ocean, as we saw in that previous figure, there are also periodic extreme warming events known as marine heat waves that are also impacting seabirds and other marine wildlife. Marine heat waves are a particular type of warm water anomaly in which the surface water gets significantly warmer than the average, and it stays that way for a period of time. But marine heat waves are not associated with any normal climate cycles, such as El Nino. We expect El Ninos, they occur on a regular pattern. But marine heat waves can form at any time, and in fact, the mechanisms for their formation are not entirely understood. It has to do with changes in atmospheric circulation patterns and ocean circulation patterns and wind strength and things like that. But they can pop up at any time, and they can have devastating impacts. So I highlight one here from 2014 that lasted from 2014 to 2016 that was called the blob. And the blob was a particularly intense marine heat wave that occurred in the North Pacific. This resulted in very low breeding success for many seabirds and mass mortality events for seabirds as well, particularly in the Northern Pacific, in Alaska and British Columbia. We saw a little bit less of an effect at the Farallones because we're further south and we still had moderate temperature instead of extreme heat, but there was still some impact from it there. And so this is just a quick review of some papers that we've written, some of the research that has come out of Farallon data and other data sources over the last few years that are documenting the impacts of these extreme heat waves. And the figure on the left shows that 2014 to 2016 heat wave, again, what we call the blob, and this increase in mortality for common MERS during that period. So the big red circles, the bigger the circle is, the more dead birds were found on beaches. And you can see that it had a really large impact in Alaska, but there was still a significant impact along Oregon, Washington, and California coastline. So these are the kind of impacts that you see from this constant warming that we're experiencing. But there is hope. Despite the many threats and challenges I've discussed that are being faced by seabirds, they are very resilient and they can recover if they're given a chance. First and foremost, seabirds are long-lived species. They're very well adapted to living in a variable environment, and they have experienced regular poor years. So and they're adapted to them. So in this example, I show an example of a study we did with Cassin's auklets a few years ago. And this is a kind of a complicated figure, so you don't have to dive into it in too much detail. But what I'll point out is that the top panel is water temperature. And the areas where it's red, orangey red, are warm temperatures, warmer than average temperatures, and the areas where it's blue are cooler than average temperatures. Then if you move down to the next panel and you look at that yellow line, you see that when there's red circles up above, so there's warm water, we see a decline in Cassin's auklet survival. So more Cassin's auklets die when there are these warm water events like El Ninos or the blob. But they are able to buffer themselves against this to some degree. During those periods between warm water events, Cassin's auklets will put in greater effort and produce more offspring in those good years. And what this does is it produces a floating population that can help buffer against these mortality events. So if you then look at the blue line, you see that a few years after the mass mortality event, so where the survival is down low, a few years later, you see this peak in recruitment. And so that's all those extra young birds that were produced during the good years that are filling in the population to replace those animals that were lost during the poor years. So they have this ability to adapt and to buffer it so that population stays stable during a few bad years. Of course, if long-term declines will occur if poor years become more frequent or if they tend to stack up next to each other in close succession. Another thing you can do to help seabirds out is restoration. And here I define restoration as any actions taken to enhance seabird populations or their habitat. It can be something as simple as protection. So when the Farallon Islands were made a national wildlife refuge, or when the main island was added in 1969, providing that protection for the seabird breeding colony gives them a buffer so that they are insulated from some of these effects and they can respond. We can also do habitat enhancement. And so that's some of the figures I'm showing, or some of the pictures I'm showing here. The lower left picture is a structure we call the Ashy Castle. And it's where we took some old concrete that was left over from a long abandoned building foundation. And we broke that up and we stacked it in such a way to make a lot of crevices for the birds, for ashy storm petrels to nest in. So we're increasing their breeding habitat. The other picture I show is what we call a Cassin's auklet nest module. So Cassin's auklets are an important species, about 30,000 or so that breed on the Farallones. And we noticed a few years ago that when we get really warm days and as the climate is warming, Cassin's auklets were suffering from heat stress that are when they're nesting in their boxes. So we have artificial nest boxes on the island that they nest in, and those were getting really heated up and birds were suffering from heat exhaustion. So we worked with other researchers and a ceramicist from the San Francisco College of the Arts to design new clay modules that are more resistant to temperature changes, and they'll stay cooler as the environment warms, giving the auklets a safer place to breed. And then what we can see is recovery. With sound, science-based restoration activities, seabirds can make a comeback. So throughout the world, researchers and managers are implementing restoration activities and giving seabirds a chance to really recover from disturbance and from negative impacts and anomalies in the environment. And we can really, by doing this, we can help to reverse some of those population declines that I discussed earlier, that 70% global decline in seabird populations. The way that we can start reversing that is through adding resilience, restoring colonies, and giving seabirds a chance to recover. So this figure is just showing some of the locations where restorations have been done and where seabird populations have started to recover, and they've been largely successful. But let's take it back closer to home and talk about common murres, which are on the Farallon Islands. This is an example of population recovery when you give species a chance. Common murres are by far the most abundant species, breeding seabird species on the refuge. At one point in the 1800s, there were as many as 1 million birds that bred on the Farallones. But egg collecting and disturbance by people going out there decimated that population, knocked it down to only a few thousand birds by the early 1900s. When the egg collectors and others departed the island and they were under the charge of the lighthouse keepers, the islands had some protection and the murres started to recover. And they got up to around 100,000 or so birds. And they stayed that way for a while until in the 80s and 90s, when the populations again were on the decline due to a gillnet fishery in Central California, birds getting entangled in nets, and a series of oil spills. But those risk factors have been largely dealt with. And since about 2000, we've seen rapid growth and recovery of the common murre population. So it's a real good success story. I'm going to briefly go through a couple of other success stories that were built off of that long-term data. So those data sets that I was talking about before, the many 58 years of data we have contributed to real conservation successes. And this is just a smattering of them. In 1975, for example, Point Blue biologists were able to successfully remove invasive rabbits and cats from the Farallon Islands. The destruction caused by rabbits basically grazing all of the vegetation and kicking seabirds out of their burrows, and cats preying directly on seabirds and on their chicks were having a devastating impact and actually caused rhinoceros auklus to be completely extirpated from the Farallones. By removing the rabbits and cats, we gave them a chance to recover, and a few years later, rhinoceros auklus did come back to the Farallones, reestablished, and now they're doing quite well. Data from the Farallones was also instrumental in helping to establish the national marine sanctuaries we have along the coast, documenting changes in the populations and resource needs of marine birds and mammals that the sanctuaries were created to protect. 1990 data from the Farallon Islands was instrumental in getting gillnet fishing banned in Central California. So the murres and other seabirds were getting entangled in these floating nets while they were out foraging for food, and that was causing a large population decline, as I mentioned earlier. So we used our data from the Farallones and talked to management councils and to fisheries industry to get gill netting closed down and to protect the wildlife. And I'd said I'd talk mostly about seabirds, but we have other resources at the Farallones as well. And in the early 90s, we were noticing that the white sharks that congregate around the islands were being hunted or fished in regular numbers, and that was having an impact on their populations. So again, we use our long-term data from monitoring white sharks to influence and inform the management agencies to close down the fishery for white sharks and to protect them and allow them to recover. This is a fun one. 1996, fur seals were recolonizing the Farallones. So northern fur seals were once extremely abundant on the Farallones, but they were extirpated not only from the Farallones, but from all of California by about 1850 due to extreme hunting pressure. They remained absent for more than a century. And it wasn't until after the Farallones were designated as a national wildlife refuge that animals first started returning to the islands. They started showing up maybe about in the late 70s, early 80s. And in 1996, the first pup was born on the Farallones in more than 150 years. And now, as of 2023, we have more than 2,000 pups being born a year. So this is, again, a great success story of what you get from really protecting the habitat. Data from the Farallones was used directly to identify important areas to protect as part of the state marine protected areas, protecting important foraging habitat for seabirds and spawning habitat for marine fish. And our data on diet, as I showed us collecting some of that earlier, some of that data was used to determine how much food is needed to support these seabird and marine mammal populations. And then we shared that with the Pacific Fisheries Management Council and shared our expert opinions, and they changed how they set harvest rules for fisheries so that they make sure they set aside enough food to support the wildlife before they decide how much can be caught in commercial fisheries. So these are all really great success stories built off of that long-term monitoring program at the Farallones. Unfortunately, everything is not all good news, and the Farallones are on the edge of a new transition. Since April of 1968, as I said, we have been providing critical data for baseline biological environmental monitoring, and that research is geared towards applied conservation efforts. But unfortunately, after 58 years of continuous presence on the Farallones, we are on the edge of this major transition. Due to budgetary constraints at the regional and federal levels, the U.S. Fish and Wildlife Service are very important partners we've been working with since the late 60s. They're no longer able to financially support the long-term stewardship and monitoring program that we do at Point Blue. And of course, a lot of that data that we're collecting in order for Fish and Wildlife to manage these resources. So they've contributed to helping its upkeep, but they can no longer afford to do that due to long-term budget cuts. There's also a backlog of significant infrastructure repairs and ongoing maintenance costs. Much of the infrastructure on the Farallones predates the refuge, the houses, the buildings, the basic infrastructure. Some of it's over 100 years old, and a lot of it is reaching the end of its life and is very expensive to maintain. And so that's also causing a problem. And without replacement funds, operations are going to have to be significantly changed, including possibly shifting to a seasonal staffing model where we're no longer on the island every day throughout the whole year. Changing to this model will have significant impacts, including the loss of critical monitoring programs that directly impact conservation policy and have been informed by data collection from us for more than 50 years, actually 58 years. But we're working to find alternate sources of funding, try to find other ways to fund these infrastructure needs, and find ways, and we're working very closely with our partners at Fish and Wildlife Service to determine how to re-envision the Farallon research program and to right-size the infrastructure so that it is more sustainable and that it can be, and we can afford to maintain it into the future. So finally today, I just want to say, if you are happy to have learned more about the Farallons today and you want to learn more, you want to get involved, there are a few ways that you can do that. First of all, please go visit our website, pointblue.org/Farallons, and read our page and learn more about it, follow the links, learn more about the work we're doing. Check in on us. Check out the live webcam. There is a webcam hosted by the California Academy of Sciences that we have up on top of the lighthouse, and it gives you a beautiful 360-degree view of the island, so you can kind of check in at any time and see what's going on. Or follow us on social media. We'll do regular updates like Farallon Fridays, where the biologist will send a picture and a short note to let you know what's going on out there. You can turn into a live event. Sometimes we do a live webinar from the Farallons, and the biologists on the island will show and explain what's happening up there. Or you can get on a boat. You can go around the islands to see them for yourselves. While you can't go on the islands because they're a closed refuge, you can take a pelagic trip out there with the Oceanic Society or someone else and see this wildlife for yourself and see why the Farallons are such an amazing place. If you're able to and so inclined, please consider supporting us financially. Go to our website and make a donation to help keep this long-term monitoring program going. And finally, support your wildlife refuge system. The financial constraints that we're seeing are not limited to the Farallons. They're system-wide for the National Wildlife Refuge System. The Farallons are just one of 7 refuges in the San Francisco Bay Refuge Complex and one of hundreds of refuges across the nation, and they need more funding. So write to your congressperson, tell them that you support wildlife refuges and their mission of protecting wildlife, and let them know that it's important for them to fund the Department of the Interior and the refuge system to protect these places. All right. Bo, with that, I will say thank you very much for listening to me. I hope I didn't talk too fast. I feel like I did, but hopefully you could understand me. And I will turn it over to Leah to moderate questions. Thank you.
Thank you so much, Pete. That was terrific presentation. Thanks so much for sharing your expertise and everything. So yes, we will now transition to questions. So if you have any questions, please drop them into the chat. And I'm going to be reading out people's questions. So yes, just please add them to the chat and we'll get to as many as possible. And I'll just start at the very top. So our first questions are coming from Claire Peasley. And Claire asks, first question is, Pete, it looks like you're in your room on the island right now. Is that correct, with flags from the Farallon Patrol?
Hey, Claire. Good to hear from you. I am actually in my home office in Minnesota. I decorated it with all the Farallon Patrol flags to make it feel like I'm on the Farallons, and it helps inspire me when I'm doing my work from here. But good eye.
Awesome. And then Claire had a second question that I think you in part already addressed, but I'll read it out loud. Last year or so, U.S. Fish and Wildlife Service funding was disrupted for year-round research and monitoring on the Farallons. What's the latest on that? And is the current disruption to federal program funding impacting Point Blue, or will it?
So Yes, we learned about a year ago of these reductions in funding that the Fish and Wildlife Service would no longer be able to support the monitoring, and that their ability to support the infrastructure maintenance cost was also going down. And this is part of a long-term trend within the service and the Department of Interior in general, in that um, funding from Congress has been stagnant or declining across the entire system, and costs, of course, are rising. And so it just gets more and more challenging to keep these things operating. So that is continuing. We don't expect that there will be a change that's going to free up more funding for that anytime soon. Although letting people know that the refuge system is important, and hopefully will lead to long-term change where it gets a little more funding in federal appropriations. As for more recent changes under the new administration, those are not directly affecting the Farallons at this point because our funding had already disappeared before that, but they may be impacting other projects throughout Point Blue that are working with other federal agencies.
Thank you for the clarification, and thank you, Claire, for your questions. Let's see. Our next question comes from Harriet. Harriet wants to know, is the rodent population under control? And if so, how is that accomplished?
Unfortunately, no, the rodent population is not under control. We've worked with U.S. Fish and Wildlife Service, and the U.S. Fish and Wildlife Services has been planning a Farallon restoration, rodent eradication for many years now. That project is still a priority, although it has not been implemented yet. So there's a lot of hurdles to get through to do a large project like that. So it hasn't happened yet. And at this point, the mice are still doing their things. They're still reaching very large numbers during the fall season and impacting the wildlife.
Gotcha. Thank you, and thank you, Harriet, for your question. We have a question from Laura. Laura's asking, do you follow the kelp population and other macroalgae?
We do not. So primarily we're working with everything above mean high tide. So I don't believe there's a lot of kelp around the Farallons anyway, but anything subtidal and out there is the purview of the National Marine Sanctuary. So they would have better data on that than we do at Point Blue.
Gotcha. And then we had a question from Stephanie who's asking, what drives the reverse migration? And I think that was in reference to the pigeon guillemot. Yes.
It's a very good question. We're not entirely sure. We do know that pigeon guillemots breed in that area already, and that guillemots from Alaska also come down to that area during the winter. So the working hypothesis is that it is a good sheltered area with dependable prey resources during the winter. Pigeon guillemots are not the strongest flyers, and during the winter storms that impact the coast around here, think about your atmospheric river storms. If those birds are staying around here, they're getting pretty severely impacted by and bombarded by those storms. So by moving up to these sheltered inland waters of British Columbia and Southeast Alaska, we suspect that they're finding a more moderate place to spend the winter that has a reliable food source. But more data is needed to find out.
Gotcha. And another couple questions from Laura. Laura was wondering, are you seeing any impacts of avian flu either in the bird populations or in the marine mammals?
Thankfully, we have not yet, but we are on the lookout. Avian influenza obviously is a very serious topic, and it's a very big concern for us on the Farallones. With these really large seabird populations, it could spread through it very quickly. So we have monitoring protocols in place. We monitor dead birds on the island. We'll collect samples and send them off for testing, just so that if there were to be an outbreak, we could be on top of it right away and take whatever potential measures we could, at least to protect the people and wildlife that we can. But I know it is a very big concern of ours. And since the Farallones are also a migration hotspot, there is always the potential for natural introduction of avian influenza from regular migrants during the fall or spring.
Gotcha. Thank you for that clarification. And also, Laura, thank you for your questions. You have some great questions. Another one is, are there particular species on the islands that are at risk from sea level rise based on where they're breeding?
Great question. Um, yes, so sea level rise for is probably most likely going to impact the marine mammals, so our pinnipeds. They breed along the shoreline and they haul out along the shoreline. So as sea level rises, some of that important pupping and haul out habitat could be inundated. That also could affect seabirds by forcing the pinnipeds further up onto the island. So instead of being in what is now the intertidal, they would be up on the marine terrace, and that's where the seabirds breed. So that would force seabirds to move. So it will maybe directly impact pinnipeds in terms of inundating their haul out and pupping areas, but indirectly it will also redistribute the wildlife around the island, thereby impacting the seabirds as well. And black oyster catchers actually would be severely impacted by that because they nest only in that intertidal zone.
Gotcha. Um, those of you listening, please drop more questions in the chat if you have them. We have one from Annette. Annette was asking, I know that Point Blue has worked with other projects in soundscape ecology. Do you foresee the use of that type of monitoring technology with the implementation of audio recorders if modes of long-term monitoring have to shift?
That is a wonderful question. Yes, we have been using some audio monitoring as part of our methods already. These automated recording units called song meters, which we've put out around the island to monitor nocturnal species like ashy storm petrels and Cassin's auklets. And we even have one out there that's used as a bat detector, so we can keep track of bats that are coming through the refuge on migration. There is potential for setting up some kind of system, audio moths or other types of listening devices to try to keep track of some activity patterns at least around the island if there's nobody going to be out there. So it does have potential.
Cool. We have a question from Allison asking about how often does Point Blue collaborate with the Marine Mammal Center and International Bird Rescue to return animals to the wild?
Oh, to actually release rehabilitated animals? Not too often, every once in a while. Most of the time, rehabilitated animals are released at the shoreline. But every once in a while, if you have a sea lion that just keeps coming back and restranding, or you have, I remember one year they had was it a Laysan albatross that they were rehabbing at the International Bird Rescue, and they didn't want to release that from the beach because it would just come back. So we took it on a boat out to the Farallons and released it from there. And we've released a few sea lions, but it's not a regular thing.
Gotcha. Thank you for your question, Allison. And then another question from Michelle. Are you still seeing the effects of DDT or other chemicals in eggshells? And is that affecting population numbers?
No, thankfully not. Since DDT has been banned, we are no longer seeing that particular impact, and eggshells are more or less back to normal for most species. So that was a devastating impact for some species, especially heavier species like brown pelicans, where their eggshells thinned and were crushed when they were incubating. We aren't seeing that kind of thing, but we do still see pollutants, organochlorides and other types of pollutants that will show up in the eggs and in the shell. But the thickness, the issue with DDT, thankfully was remedied by banning DDT and getting that pollutant under control.
Gotcha. We have a question from Robin asking, why do pelicans not breed on the islands?
That's a good question. I think primarily because pelicans like warmer areas. So they do breed from the Channel Islands south and down into Mexico. They do roost on the Farallones very regularly, especially outside of their breeding season. And we'll see sometimes very large numbers of them, up in 5 or 6, 7,000 of them. They haven't started breeding on the Farallones yet, but as ocean conditions continue to warm, we're seeing more warm water species spreading up into central and northern California. And it's completely conceivable that in another 10, 15, 20 years, pelicans would consider breeding in the Farallones because the waters around them would be warm enough.
Hmm. Gotcha. Thank you. And then a question from Joanne was wondering, do you share data with the Farallon Sanctuary Association Beach Watch program?
We do work closely with them. We share a lot of data with the sanctuaries in general. And I don't know if we share a lot of data directly with Beach Watch unless they request it. But yeah, we're always willing to share their data with other agencies and other nonprofit groups that are doing conservation work. The idea is more data spread around, the more work can get done. So,
Awesome.
but
Thank you.
yeah, I guess one point I would make is when we were looking at that one map that showed the common murre carcass deposition along the coast during that the blob 2014 and 16 marine heat wave. A lot of that data comes from Beach Watch and similar programs, so that helps inform what's happening there.
Gotcha. Thank you. And then one question from Jennifer. How do you track the movement and dispersal of common murres after they leave breeding or nesting grounds?
So murres, the only tracking work we've done with murres so far is short-term tracking, looking at their foraging during the breeding season. We haven't done any tracking work with murres yet to see where they're going, but based on at-sea surveys and pelagic trips and things, and the fact that they come back to the island pretty regularly throughout the fall and winter, we understand that murres are primarily staying local, so they're not going very far. But it would be something that would be nice to do, and in order to get to that point, we need to just find different types of technology, smaller trackers that will stay on the birds throughout the winter and that we can recover data from. And we haven't done that yet.
Gotcha. Thank you. There's a lot of messages coming in about great presentation. Thank you so much, Pete. Some people were saying, yeah, just excellent talk. So thank you so much. And one
Thank
question
you.
from Annette came in saying, the long-term monitoring data, is there any provided as open space data, open source data? And is there any current need for research assistantship volunteers through the various projects on the island?
So first, we do share our data in a few different places. There's what's it called? The Integrated Ocean Observing System, IOOS, especially CENCUS, Central California Integrated Ocean Observing System. We share a lot of our monitoring data through their portal, so it's available for a number of years. And we share it with other agencies like National Marine Fisheries Service, the sanctuaries, obviously Fish and Wildlife Service. So there's a few different places where it's available. We also are sharing data through another website called Research Workspace. That isn't completely open source. Anybody can access it and request the data, and then we make it available. As for research assistantships, at the moment, we do not have any available. We've just recently filled all the positions we have for the spring-summer seabird research season, and we haven't started thinking about the fall season yet. And there's a possibility that we'll have to shut down and depart the island, in which case we wouldn't have a fall season. But if we are able to, if we can find the funding and keep the place operational, then we would start looking for those probably midsummer.
Gotcha. Thank you so much. I think that we can wrap up there. Actually, it is the top of the hour, but thank you so much, Pete, for sharing this talk with us and just sharing everything about your expertise of seabirds. And yeah, thank you everyone for joining. I think this was a terrific talk and just a great presentation. There's a lot of comments coming in saying, thanks for the excellent presentation from Houston, Texas. This was wonderful. Thank you. Thank you so much for this presentation. Yeah, it was a lot of appreciation in the chat for you, Pete. So thank you so much. And thank you everyone for joining and hope to see you at a future talk.
Thank you, everyone. Keep up the good work. Support Bay nature and conservation.
Take care, everyone. Have a good day.